हेलो, कैसे हो?
मैं मोटा लग रहा हूँ गर्ल्स
नहीं तो पता है, कॉमेंट्स में बोलता है तो मोटे लग रहे हो, तो
अंदर ही बैठी अल्लाह सर का काम देख रही है।
हाँ, वो मेरे बारे में तो जानती है। मिलूं क्या?
क्यों मिल लो, तुम्हारी मर्जी।
कुछ छूट तो नहीं गया या कोई इमेज ढंग से आ रही है नहीं क्योंकि मेरे लैपटॉप पे तो सब कुछ सही होता है when it comes over here it might be get changed start कर दो okay. A very good morning to all. In today's session, I'm going to begin with the probability distribution. What are the forms of the probability distribution along with the numerical aspect? Let's study today. So let's begin with the introduction. Probability distribution is a function that truly gives the chances or the likelihood of the occurrence of you can say the values of a random variable in a particular sample in a particular you can say data set. Or in other words, we could say it also provides the relative you can see likelihood of the occurrences of all the possible outcomes which are being included in a data set or a given sample or experiment. Basically, there are two main functions which are mainly to describe or to reveal a probability distribution. So when it comes to the probability distribution, there are two main factors, that is the probability density function or the probability mass function. These two basically functions relate to the discrete and the continuous probability distribution of a random variable. And when it comes to the you can say cumulative distribution function, that is also relate to the discrete and the continuous you can say probability distribution. So in other words, we could say the probability distribution is a function that actually gives a relatively likelihood of all those occurrences of which it relates to the possible outcomes in a given sample in a particular scenario. So two important main functions which actually relates to the probability distributions are probability density and the probability mass and the cumulative probability distribution function. So let's begin what is exactly the probability distribution is. So probability distribution, the concept of this term, that is probability distribution, is mainly used to provide or to give the probabilities of all those possible outcomes that the random variable can take up from the given data set. It categorized into two main parts, that is called the discrete probability distribution and the continuous probability distribution. When it comes to the discrete probability distribution, is described by a probability distribution function and the probability mass function, where the infinite values is to be considered, and from the infinite values the probabilities of the all of the occurrences of all that possible values will be calculated. So that is called the probability mass function. When it comes to the probability distribution function, it refers to an infinite values, but infinite values it will be selected who have a higher probability, or you can see the higher frequency values where it comes, and accordingly the probabilities values is to be estimated in case of discrete probability distribution, which is described by the probability distribution function. That is the function of the values of the random variables. When it comes to the probability distribution function or a probability density function, where the infinite values of a random variable will be considered, but sometimes it is very difficult to apply the infinite values and how the probabilities to be estimated in a real life applications. So the probability distribution you can say it's difficult, or it's a major challenging task to apply in a real based applications or the scenarios. In fact, such tool is mainly used to test the hypothesis testing, and there are plenty of the tools where we test the hypothesis like standard normal distribution. We can talk about the chi-square distribution. We can talk about the t distribution. We can talk about the F distribution. These are the statistical tools, or you can say the other types of distribution where we can use to estimate the values of the probabilities of a discrete or the continuous frequency distribution data set. So when it comes to the continuous, you can say probability distribution. So there are two main functions being used under this category. That is the probability distribution function and the probability density function, which are mainly used to describe the continuous probability distribution. And there are various types of, you can say, probability distribution under this continuous and the discrete. That is the binomial probability distribution, and in other words we can also talk, you can see that is Bernoulli, that is we can, in other words it is called a normal probability distribution. Geometric distributions are the few examples of the probability distributions. Now we talk about what is exactly the probability distribution function. The probability distribution function, in other words, we can also call the cumulative distribution function, where these terms is already used in the introduction of the probability distribution. Now, when it comes to define each of these terms. So the probability distribution function is also called the cumulative distribution function, which is called CDF. If there is any random variable, say a x, and its value is to be estimated, say a value or at a point, say x, that means the probability distribution function gives the probability that actually the value, probability of x will give a value either less than or equal to small x. In other words, functionally, we can also write as the function of x that is equal to the probability of x, which is you can say less than or the equal to x. So this is how it to be written functionally, the probability, the function of the random variable x, which is equal to the probability of x, which is less than or equal to x. Furthermore, or moreover, if there is any semi-closed intervals, like we can talk about A to B, B to C, C to D, then in that case, how the probability distribution function is to be described mathematically. So this is a way that we can use up this concept. So when there is a semi-closed intervals given by A and B, let's say A and B, then the probability distribution function is given by the formula, that is P, probability of A, which is less than the X, and which is less than or equal to B. That, in other words, we can say that is a function of B minus the function of A, and that is called the demand distribution function. So when there is any variables, random variables given, or any other value is given, so automatically the probability of that value is to be estimated. But how to represent that function which has been described on this particular screen? So when it comes to the probability distribution function, the values of the random variables always equal between or lie between 0 and 1. And ultimately, it is also, in other words, we can say it is a non-decreasing function as well. So whatever the value is to be estimated in case of the probabilities, so the whatever the values being estimated, that is lie between 0 and 1. The next one is the next concept is the probability distribution of a random variable. So automatically the probability distribution of random variable is classified into two main parts, that is the probability distribution of a discrete random variable and the probability distribution of a continuous random variable. So when I talk about the what is exactly the random variable is, the random variable is described, it could be any variable that ultimately gives a possible outcomes or possible values of that particular outcome or possible outcome of a particular data set or a sample. That is called the random variable. So random variable could be any variable that gives us or shows the values of a possible outcomes of an experiment or a sample or a data set. That is exactly called the random variable. So there are two main types of the random variable, that is discrete and the continuous random variables, and based on the formulas of each probability distribution of a random variable are classified into two main parts, that is the probability distribution of a discrete random variable and the second is probability distribution of a continuous random variables. So let's begin with the to understand these two main concepts, and ultimately these two concepts will be used to estimate the or to using the another type of the probability distribution. We can talk about the normal distribution, binomial distribution, and the Poisson distribution. So let's begin with that. So the probability distribution, what is exactly the probability of distribution of a discrete random variable? So a discrete random variable can be defined, it can be defined as a variable that values would be countable. It would be begin into a series by 0 to 10 to 100 as well. But the formulas for the probability distribution function and the probability mass function is already mentioned over here. So discrete values are refers to you can see the individual values that can be countable, and based on that the particular if functions or equations could be formed in case of discrete random variable. So the probability distribution function, that is the function of x which equals to the probability of x in respect of their value, it would be less than or equal to x. When it comes to the probability mass function, which where the you can say the probability of x is equal to the probability where the values are exactly equal to the values or the possible outcomes for the random variable, say x. So this is how the equations is to be represented when we consider the case of a discrete random variable. Now we come up to the next case, that is the probability distribution of the continuous random variable. So when it comes to the continuous random variable, it can be defined, could be any variable that where the series or where the values of a particular random variables are infinite, which have a many values which have no and exactly. So as the probability, which is a continuous in nature or which is refers to a continuous random variable, which always take up an exact value. So when we calculate the probabilities of the continuous random variables, so automatically it will be estimated with the exact value of 0. So we can under this particular concept, we cannot consider the probability of the masses of values where to describe the probability distribution. So whatever the formula which is being described in the one on the various types of the probability distribution, say a normal distribution. So the formula which will be used to calculate the probabilities under the discrete and the continuous random variables Accordingly, it will be estimated, and the one exact value is being estimated of the probabilities of such continuous random variables. So few how it would represent in the form of the functionally, that is the probability distribution is equal to the function of x, which equals to the probabilities of x in respect of the values, that is called x, small x, that is the probability of x which is less than or equal to x. Now we come up to one, you can say the certain types of the probability distribution, and one of the type is called normal distribution. So in the probability theories or statistics, the normal distribution is also called, in other words, that is the Poisson distribution, which is one of the most significant type of the probability distribution in case of continuous random variable. So sometimes, in other words, we can also call a bell shape, where the shape under the normal distribution is bell. So automatically, when it comes to the continuous, where the normal distribution concept is being used, so a large number of random variables, which is called infinite values, are either nearly or exactly could be represented by the one of the main type of probability distribution, that is called the normal distribution. And when it comes to the usage of normal distribution, it mainly used in the physical science, in the economics, specializations or disciplines. So moreover, it is absolutely shows the exact value of the random variable, and is one of the most appropriate method, or categorized as a one of the method of other, or as compared to the other probability distribution. And of course, it always support with the description of a word, that is called the normal, as the normal shows normal values or infinite values, where it's always been mostly being used when it calculate the probabilities of random variables. So when we come up to the mathematical formulas, these are the two main formulas of normal distribution case. So that is the function of a variable, that is x, the function of mean, that is you can say a function of standard deviation, which is equal to 1 by standard deviation in root 2 pi, and that is e, that is into e, that power, that is minus x minus mean. X is a variable and mean is a particular sample by a 2 standard deviation square, and that is the whole square of a difference between the variable and the mean. So this is how the you can say the function of these three main variables, where the mean and standard deviation is to be estimated. Sometimes in the question, these two values is to be given. How to calculate the normal distribution or probabilities of a particular random variable in case, or using the concept of normal distribution, this formula will be opted in that particular scenario. So there is a discrete data is to be given. First, you need to calculate the standard deviation. You need to calculate the mean and the pi variable, and the e factor values is to be considered on the normal probability distribution tables, and accordingly we estimate the values. There is another concept where we used to estimate the z-score formula, where it's mentioned when we you can say estimate the difference between the values of a random variable, that is say x, and the mean, and by divide by the standard deviation, it becomes the z-score formula under the normal distribution case. So we can easily estimate the Z scores based on the main formula that has been given. So if you look up the factor E where the power is already the formula, there is a formula given in the power that is minus x by mean by 2 standard deviation square and the whole square of the difference. But when from this particular formula, the z-score formula has been derived, which is equal, z is equal, that is the difference between the x variable minus mean by standard deviation. So if you need to calculate the probabilities of any head or any tails, or at least head or most of the value of any of the random values, that is 2 3, and you use to calculate the first z score, and accordingly you can easily calculate the probability under the case of the normal distribution. So we will coming up the questions to make you understand that how this formula is to be used, and when it comes to use these formulas, the normal probability distribution tables or the probability distribution table is to be used. Now we come up to the normal distribution curve. So when it comes to the normal distribution curve, there are automatically, when we draw any such curves, we always take a values of the random variables, say x and y or z. So automatically, when we need to draw a normal distribution curve, because we need to calculate any uncertain values in a given set of data or a data set or in a given ranges of particular data or a sample. Let's take an example to understand this concept. So let's find out the height of the students in a school. So the distribution can be considered any value in between 0, between 0 to 6 or 6 to you can say 8 feet. So it will be bounded. So we need to prepare the ranges that under how many students would comes under this range, how many students would comes under another ranges like 6 to 8, then 8 to 10 feet, how many ranges, how many students would come under this ranges. So sometimes when it comes to the physical examination of a particular individual or a student, so this limitation is always put up to our queries, that it really, because there is a certain restrictions of the height and we cannot go beyond that particular range. So that this is how the ranges is to be prepared under the ranges to be prepared to understand the normal distribution curve. So automatically, whatever the ranges is to be considered, it's written, it's minus you can say infinite values or to positive infinite values. So when we consider the positive and the negative values all together in a one curve, we will get the smooth curve based on the values of a random variable. It could be such variables, it could be the discrete or continuous variables, and of course whatever the probabilities comes, it could be that value, the probability is being estimated, and whatever the value is to become, that lies between the ranges, that is the minus infinity and 2 plus infinity. So whatever the values it could become, that is in the left side, and the values with positive that come to the right side. So any value which comes using the data which is negative, we can look up the particular exact value of the curve that is on the left side. If any value it comes in the positive, that seem to be right side, and accordingly the exact value that comes within the range that is to be estimated. And this is what has been given, whether it is discrete data or the continuous data. So any probability value which always lies in a particular range, or under the ranges which has a range which has been described under normal distribution curve, that is the minus infinity to plus infinity for a particular given experiment or a sample. So we can talk about the normal distribution standard deviation. So basically when it comes to the standard deviation, so normal distribution values is totally depends upon the values of the standard deviation. It could be the smaller when suppose the standard deviation value is the smaller, then of course the data is somewhat closer to each other and the graph becomes narrower. So when we talk about the value of the standard deviation is larger, then of course the data is more dispersed automatically. When there is more data is more dispersed, the graph is a more wider. That means whatever the graph would be, really difference would be the large one. So automatically, if the values are smaller of the standard deviation, the graph would be the nearer one. So this is how the values of the standard deviation and the shape of the normal distribution curve will be dependent on on the concept of the standard deviation. So automatically it will always portray the symmetrics graphs, which would be the narrower, which would be the wider. So this curves, the values of the standard deviation totally depends at how much the shape of the curve would be the wider, it would be the narrower. So the standard deviation or the concept of the standard deviation are used to subdivide the areas, the left side or the right side, or it could be the center one. So automatically, whatever the values of the standard deviation, it could be the one standard deviation value, it could be the two standard deviation value, it could be a three standard deviation value. So automatically, when the values it categorized into one, two, three, so automatically the area is also being divided in a particular graph, and every subdivided section, it's automatically the percentage of data is to be given and a specific reason is to be shown in the graph. So automatically, to conclude this concept, the shape of the normal distribution is dependent upon the values of the standard deviation. It could be the one standard deviation, it could be the two standard deviation, or it could be three standard deviation, and depend upon the area of that particular reason of the graph is totally define the shape of the normal distribution in case of probability. So these are the rules of the standard deviation. First standard deviation. So, and this is a particular graph of that. So automatically the rules of the standard deviation stands the three main rules. This is called empirical rules, where the 68% of data falls within one standard deviation. If there is a one value of the standard deviation comes from the mean, that means the 68% data would cover. It could between mean minus standard deviation on the left side and the mean minus standard deviation on the right side. So if you have a look on have a look in the diagram, that 68% data is covered, where the left side all the negative values is to be mentioned, that is the standard deviation, that is mean minus one standard deviation on the left side, and on the right side of the same 60% data is covered, that is mean plus one standard deviation. So when it comes to the second rule, that is 95% area is to be covered, or the reason of the graph is to be covered, that means in the second category of the data falls, that is 95%, which comes under the second standard deviation. That means in the second category of the 95% of data where the mean plus on the left side we can talk about the mean minus 2 standard deviation. On the right side we can talk about the mean plus 2 standard deviation. When there is a when there is 99.7% data is to be covered, that to be covered within the range of third standard deviation, that is 3 standard deviation, where on the right left side we can talk about the mean minus third standard deviation. On the right side we can talk about that is the mean plus 3 standard deviation. That means the empirical rule of the standard deviation in case of the normal distribution is called from 63, 68 to 95 to 99.7, which automatically covers the 100% area where the exactly two parts of the areas is divided, that is the negative values or the negative standard deviation 1, 2, 3, and on the right side of these particular areas or percentage of the reasons, that is the positive 1, 2, 3 standard deviations. So, and when these particular percentage is covered in the one area, this curve is actually called the normal distribution curve. In other words, we can talk a bell curve. So this is how it looks, the bell curve under the normal distribution or normal probability distribution case, where these particular percentages has been classified and where the area is also being divided from the left and right, you can see side. And when it comes to the peak period of the bell cake, that is called the mean. That is equal to mean. And based on the mean, the area of the standard deviation and the percentage is being classified. So this is called the probability table values, where, as I already told, that it's totally based on the Z score formula, where what is the formula we can talk about, that is the values of X minus mean by standard deviation. So if let's take an example, if the Z score value comes 0.5, so automatically when it comes to the point 0.51, so we can talk about the Z score value is 0.5, and where we look, that is 0.01. As I already told that we need the value of a Z is 0.51. So automatically the Z score is 0.5, but where we have to see the percentage value, that is 0.01. So when it comes to the 0.5, the value of the probability based on the Z score value, that is 0.6950. Let's take another example to understand this table. Let's take the Z value is 0.64. So the Z score value is 0.6 considered in the table, but where we can get, how can we see or how can we get the exact value of the Z's based of the probability, the exact value of the probability based on the Z score. So I already told that 0.64 is a value of the Z score, and the Z value is 0.6, and where we could see that is 0.04. So we can classify the two values from the Z score value, that is 0.64 4. So 0.6, it's already seen in the z-score, but how we can calculate the value of the probability of a z-score? So another value would consider that is 0.04. So accordingly, the value would be from the considered or calculated from the table, that is 0.7422. Let's have a more understanding to estimate the values of the probabilities based on the normal distributions. Let's the z value is 0.89. So automatically the z value is 0.9. So automatically what the value of 0.98. So another value would comes from the z is 0.08. So from z's value is zero point 0.9, and we can look up the value of 0.08, that is 0.8106, and that would be the answer of the probability of the z-score value, that is 0.098. So 0.098, the value of probability is 0.8365 rather than 0.8106. So the value of zero probability of a z-score value is 0.98 is equal to the 0.8365. So this is how we can look up the probability distribution table, and we can easily estimate the value of probabilities of the exact random variable. So this is a continued version where the z-scores begin from 0, and would end up to the 3.4. So this is how, and whatever the value would come, let's say the value is 2. You can say 12. So automatically the 2.12, if the values come to 2.1 is a z-score value, and automatically 2.12, that means 0.02. So just look up to the you can say top column wise, that is 0.02. So when you look up the 1.2 and look up the value under the 0.02, you will get the value of the probabilities. So this is how you can look from the value, you can calculate the value of the probability based on the z-scores, whatever being calculated. So normal distribution properties. So in the normal distribution, the main three measures of central tendencies are equal, that is mean, median, and mode. The total area of the curve, which is equal to 1 only. And of course, the normal distribution curve is a symmetric curve. So the bell shape, in other words, we can talk about it is always symmetric to the center. Why it is symmetric to the center? Because the center vertical line is mean, and based on that, the area of the regions is being divided based on the value of the same standard deviation, that is 1, 2, and 3. There should be an exact half of the values, as I told, the half the same symmetric to the center, the half of the values would come on the left side, and the half of the values comes on the right side, and that is one of the property of the normal distribution. And based on the properties, we had tried the curve accordingly. The normal distribution should be defined by the mean and standard deviation, as whatever the z-score value is to be estimated, and then the formula is also given, it is totally dependent on the values of the mean and standard deviation. And the normal distribution curve must be on the one peak, which is called a unimodal, where these two concepts and the values of the random variable is to be considered. The curve is also approaches to the x-axis, but it never touches. As you can see, the bell curve which never touches to the x-axis. If you look up this property in the particular diagram, this is, so just have a look of the bell-shaped curve, which is not being, one of the property is the curve is not touched at the x-axis. So automatically this is also the one of the property of the normal distribution curve, that the normal distribution curve must have only the curve which is approaches to the, once the curve is approaches to the x-axis, it never touches, it extends the further way from the mean. It's always extend the, this is a curve which never touch, is always extend the you can say from the mean values. So these are the properties of the normal distribution curves. It comes to the applications, that how the normal distribution is being used when there is a marks scored at the test. We can also use this concept when we need to estimate the probabilities of the heights of different people, different individuals of the persons. We can also use this concept when we need to estimate the sizes of the various objects which were produced by a machines. We can also use this concept of the blood pressures or the diabetes, or you can say the values which occurs into the ranges under normal ranges. This particular concept which also being considered under this particular real life applications. So let's take up the, you can see the question of a normal distribution curve. So a bottling company uses a filling machine to fill a plastic bottles with the apple juice, and the bottles are supposed to contain 200 ml. So in fact, the contents vary according to the normal distribution curve, where the mean is already given 198. The standard deviation is also given, that is 2 ml. And of course, what is the probability that an individual bottle contains greater than the 201 ml? That means it is a value of a random variable, say x. So we need to calculate the probability of an individual value which is greater than the 201 ml. So how we can drive the function of a probability which is greater than the 201? Just have a look. That is, p is always a function of x which is greater than the another value of the x. That means p x is greater than the 201. And how it would drive to a function of the probability, that is, probability is a bracket, you can put a bracket on it, that is z, which is greater than the formula of the z score. And what is the formula of the z score is, that is the value of x minus standard the minus mean by standard deviation. So the value of x, because we need to calculate the probability of a of a value that of random variable, say x, that is 201. So the x is 201, and the normal distribution, the mean is already given, that is 198, and the standard deviation is also given, that is 2. So it would be 201 minus 198 by 2. So automatically, when we divide the value of this, the formula which always been considered 1 minus, that is whatever the z score value would be. So when we calculate the any probability, how to calculate the z score value, which is already mentioned in the formula, that is x minus mean by standard deviation. But when we calculate the exact probability which is greater than you can see the exact individual bottle value, which is a random variable, say x, which is called the individual bottle, the total area we need to calculate, that is 1 minus z score value. whatever the table value would comes from the based on the Z score. So this is a formula that we used in case of the normal distribution curve. So has we got the value is 1.5. So the Z score value is 1.5. So we have to look this Z score value and calculate the value of a table in case of normal distribution. So 1.5 value is being estimated as a Z score value. So we have to look this value into a probability table. So let's have a look. 1.5 is a Z score value. So we come up again with the table that is, so this is the same table which has been given in the question. So let's have a look. This is a table of a non-probability distribution or a probability table. The value is 1.5 and no other values is being given in the particular calculation. So 1.5 is the value where no 1.50 we can assume. So 1.50. So that means we can look up the Z score is 1.5 into a column that is 0.00. So there is no, if it is written 1.51, so under the 1.5 we can consider that is 0.01. If it's written 1.5, no other value, so we can consider the point values, that is 0, that is 0.00 under 1.5, and the value of Z score of table value, the probability table value of the Z score, that is 0.9332. So this is a value that how you can look up the value under and to estimate the probability table value based on the Z score. So the value has been estimated, the probability table value, that is 0.9332. If you look up this, that is it's written 1.5, which in front of 1.5 the value is estimated, the probability table value, that is 0.9332. So let's come back to the question, numerical question, as the value of the probability table value based on the Z score, that is 1.5, is being estimated, that is 0.9332. So this is a value which has been estimated, that is a probability table value, and the formula, that is 1 minus whatever the table value of the probability comes, we just subtract, and then you will get the probability of the variable which is, or the value which is greater than the 201 ml, and that is 0.0668. So this is the probability of an individual bottle that contains greater than the value, that is 201 ml. So the formula that you need to calculate of any probability, 1 minus Z score value. So if you need to estimate the Z score value, you need the three main tools. That is the value where that what value the probability is to be estimated on what value, that is 201. Mean is already given in the question, standard deviation is given in the question. Just put the values into the formula, you will get the Z score value. Just subtract subtract with the 1, that is you can easily estimate the probabilities of any other variables that contains less than or more than of any of the values. And this is a way that how to calculate the value of the probabilities based on the Z scores under the normal distribution curves, which is one of the type of the normal probability distribution. This is also the another question where the test scores of the students in a class test has a mean of 70 with the standard deviation of 12. What is the probable percentage of students scored more than 85? So as it is more than 85, you need to, your first task is to calculate the Z score. So what would be the Z score is, that is 85 minus 70, as you need to calculate the probable percentage of the scores of the students to score more than 85. So the value of x is 85, the mean is already given 70, and the standard deviation by 12. So you will get the 1.25. That is a value of the Z. To form the Z score table, you need to calculate the probability table value, which you need to go back from the table. You need to check that is the Z value, that is 1.2, and from the column value, that is 0.05, you will get the table value, the probability table value, that is 0.8944. So let's go back into the table. Let's see whether this value, probability table value being considered over here, it's or written over here, it's correct or not. So let's go back into a probability table, and the Z value is 1.25. So let's go back into a table. So this is a table, the value is 1.25. So if you look up the table, that is Z, that is 1.2. And in the second value, we have to check on, that is 1.25. So we can consider its second value based on the column which has been given 0, 0.00, 0.01, 0.02, 0.03, 0.04. 0.05. So 0.05 is being considered because the Z score value is 1.25. As 1.2 is already being considered as Z score, to check on the values, and the balance value is it's 0.05, which has been seen over here. And what would be the value? That is 0.8944. So this is a value, table value, probability table value has been estimated, that is 8.8944. So let's check on in the quotient. Table value is 0.8944. So yes, the value is same. That means it's absolutely correct, that probability table value based on the Z score value, that is 0.8944. That means from the table, that means we can say in other words that 89.44% of the students scored within the test score of 85. But as the formula which we need to deduct, then we will get the probable percentage. That means we get the 89.44%. Just subtract this percentage with the 100%. You will get the exact percent of the students score who have scored more than 85%. So as we just deduct 89.44 from the 100%, you will get the exact percentage of the students who have scored more than 85%, and that is 10.56%. So 10.56% is exactly the number or probable percentage of students who have scored more than 85%. So as the data is given and the answer is being asked in the percentage, so we just deduct the table value from the 100%, you will get the exact percent of the students. If the percentage is not being asked on the total base, you will ask the probability based on the values. You just deduct from the exact table value from the one, you will get the probability of that particular random variable values. And same, it is a percentage, so we just deduct 89.44% from the 100%. You will easily get the probability of the exact percent of student who have scored more than 85%. So this is how the question is to be done based on the normal probability distribution case, and it is very easy. This is not at all difficult to understand, but you need to check on the, you need to know to understand how to check on the values in the table. So this is how you can estimate the values of normal distribution curves. The next concept is binomial distribution. When we talk about the bio, so automatically we always talk about the two possible outcomes or the two possible results in a, which can be seen in a particular experiment, in a particular data set, or in a particular in a particular, you can say, sample, that could be either success or failure. So if let's take an example. We toss a coin, so it could be two possible outcomes, head and tail. So it could be pass or it could be fail. Let's take a class test in a particular subject. So either you could fail or pass in that particular subject. So when there is two possible outcomes, that exactly called the binomial distribution. So in the binomial distribution, there are two main concepts, that is n, that is p. N is a number of times the experiment could run, and the p is a probability of any one outcome. So when we talk about r, that is a probability of the failure, that is 1 minus p. So in these three concepts are mainly used, that is NPR. N is a number of times a particular value occurs on a given sample. P is a probability of any one outcome, and R is a probability of a failure, that is 1 minus P. Let's take an example. Suppose a dice is thrown randomly 10 times. So n would be the 10. The probability of getting 2 for every one throw is 1.1 by 6. So when you throw the dice 10 times, so what would be the n is 100, in p, that is 1 by 6. So automatically, this is how the binomial distribution could work. So binomial distribution example, theoretically finding how to find out the quantity of raw and used material while making a product. So while making a product, you can, when you estimate the basic parts of the materials that you used in making up the product, you can use binomial. It will be x, fail or pass. You can consider it. If you have exact quantities to be used, of course it pass the particular product. Taking a survey of the positive and negative reviews from the public. Let's take an example of Pushpa 2 movie. The reviews, either positive or negative. Positive, it could becomes to be a more and more successful, and negative, it becomes more and more, you can say, downfall of a movie, or of course, or a budget. It could be a negative perspective, we could say. So this is how the binomial distribution concept will also be used in such particular scenario. We can also take this particular concept when we need to calculate the probabilities of the yes and no type of surveys, where we need to check on the how many persons or the people views the particular channels or views the particular movie in a hall. So and thus practical expect us to find out the males and female employees as well, and the number of votes to be collected. So this is the exact scenarios of the practical or real-based situation where this concept is being used. Thank you for all for listening this lecture. So I'll come up to the more and more interesting topics in this particular blog. And namaste to all.